today we're going to find out if the food that we eat are basic or acidic. The everyday foods that we see around us each have a specific pH to them. And we're going to test that by using our pH litmus paper. There's also red and blue, but this is universal. It changes colors according to what the pHs are. As you can see, if it turns red, the pH is close to 1, which is very, very acidic. And if it turns purple, it will turn it means that it is very basic. We're going to experiment with foods such as lemons, limes, oranges, and we're going to test our olive oil and baking soda. These are known to be very acidic, if not a little. In order to test these, we're going to squeeze the juice into each of these cups. Okay, so over here is our lemon juice, over here is our lime juice, and over here is our orange juice. So each of these are different fruits, so we are predicting that there are different types of pH. However, their pH should all be acidic because they are citruses. Before we demonstrate with our litmus paper and our pH scale on the pH meter, we will get a volunteer to do some taste testing so that we can prove that all acidic foods and acids taste very sour.
Yeah, I saw you drowning it in soy sauce.
And he's going to drink the orange juice first to see how it tastes.
Let's go, Brian. It's okay. It's okay.
How to describe it? Is it sour? Is it salty? Is it sweet?
A little salty and sour.
A little salty and sour. Alright, okay. Kind of expected.
Now this is a lime juice.
Ooh.
Very sweet.
Very sweet.
Yeah.
Is it sour too?
Not sour, just sweet.
Oh, wow. Alright. It's gotta be sour.
That's the lemon juice.
Very good.
Very good.
Yeah.
Very good. Just
Out of which of them were the most sour?
Most sour is probably
The lime?
the lime.
Okay. And then which one?
Probably say
The lemon?
the lemon.
And then proof that these were clearly acidic because of the sour taste. We're going to test it out with our pH paper to find out the approximate pH of this. First, we're going to use our litmus paper, universal litmus paper, which will tell us approximately what pH these three liquids are. So first we dipped into the lime one, and it turned red. Clearly pH of 1.
I was like the peppers that were.
It's very acidic. And we put it in here, and
The peppers
it also turned red. We're guessing a pH of
Oh, I
1,
thought you didn't want it.
but it seems a little lighter than this one. Maybe it's about a 2-3-ish on the pH scale.
Not too bad. Not as bad as the steak right now.
And for the orange. And when you put it in, as you can see, it's still orange. And on the pH scale, that's about a 4, so it's not very acidic as much as these are. Another test we're going to do is with a blue litmus paper. Blue litmus paper tests if a solution is acidic or not. So when we stick this into an acid, the blue litmus paper will turn red if it gets in contact with some hydrogen ions. As you can see, Our blue litmus paper has been turning red, indicating that this is clearly an acid. Now we're going to use our pH meter to see if this is at a pH of an acid. As you can see, the pH meter is indicating a really low pH of 1.72, around there. For this specific one, which is the lemon juice. Lemon juice has a pH of approximately 1.5 to about 2.
Oh, can I borrow that? Please, cash. Okay, and then you're going to put your pie cup on here.
For the lime one,
Miss Keller, should we just throw this
also
out?
shows
We're
that
not going to eat it.
it has a pH of about 1.7, 1.3. It's going around there. Very acidic. And this will be predicted to have a higher pH than these two because this orange is not very acidic, but it's still acidic. As predicted, it has about a pH of 2.2 to 2.4. Okay, over here we have our baking soda, which is predicted to have about a higher pH than 7. It's basic, it's known to be basic, and our olive oil, which is also known to be basic. We're going to test the pH of them to make sure that they are basic and to prove that they. We're gonna go mix this to make a solution that is very well stirred, so our data is accurate. Okay, this is a baking soda solution. It is predicted to be basic.
And we can, like, see how they make
And we will take a cup and take a sample of the baking soda. And we will take another cup and take a sample of the olive oil. In order to tell the pH, we will get our first our red litmus paper, which will turn blue when it comes in contact with bases. As you can see, it will clearly turn blue, indicating that this is a base, indeed a base. But the olive oil, it seems like this is not a strong base, or just basic in general. So the olive oil failed. However, we could still work with the base baking soda. In order to conduct the second test, seeing if it's basic or not, we will use our universal indicator. Maybe this will tell us if this is basic at all, the olive oil. If you look on the universal pH meter on our litmus paper, you could see that this has not turned in color, so this has no pH, it seems like. Or just simply yellow, which is at a pH of 7. This is neutral. However, over here, it turned into a green color, indicating that this has a pH of 8. So this is indeed basic. So, what we will do now is we will get the pH meter again and test it for the right pH. Clearly this is not working. But if we put it in this, the pH meter is rising above, it's going up and up and up and up above 7. It passed the neutral point, indicating that this is basic. It's going up to 8 and still rising. 8.2. For our sake, it's approximately 8.3, although it was rising. So, one of the common reactions in chemistry is called neutralization reaction, is when basic solution and acidic solution come together and they will neutralize each other. The best example would be when each of them have pH number of approximately 1 and 14, both extremes, about equal amounts. 1 molar HCl and 1 molar NaOH will show the best neutralization reaction. However, we have a pretty weak base and strong acids. So, but we could still show that the pH changes when a really acidic solution comes in contact with a basic solution. The pH will change. So in order to show that, we're going to mix the baking soda with the one of the 3 or all 3 acidic solutions that we found.
Just a little bit of.
Okay. So we will get one of our cups. We will put a little bit of lemon and pour it in here. As seen before, it has a pH of about 1 to 1.4. And we get our baking soda and we will mix it. That is what happens when base and acid neutralizes. It bubbles up to produce hydrogen gas. And notice how we found out that the pH of the base was 8 and the pH of the acid was about 1.4. If we use one of the litmus papers to check for the pH, we will find out the pH of this, of the neutralized solution. As you can see, it's orangish, yellowish, indicating the pH is about 6.5. So it's not as acidic as the lemon juice was before. It's a bit higher, up to 6 and 5, and that's because the base raised the pH up to 6, so it's not as acidic as before. Now we will use the pH meter. Dip it in here. It's dropping, showing that the universal indicator of the litmus paper was correct. It is dropping down, going down.
Alright, turn around here please. In a week and a half's time, when I tell you that you're going to have a test, and you're all going to ask about...
It dropped down to below 7.
They're right there on the
It's around 6.9.
my only concern is...
So we're stirring it a little bit to see if we could get more reaction out of it. And yeah, it's about 6.8. So we found out that when I get a strong acid about pH of 1 along with a basic solution with a pH of 8, when they are mixed, the solution's pH is more on the acidic side because the acid solution's pH was much lower than basic solution, because basic solution wasn't much of like a strong base. It wasn't as in the extremes.